Well, hello there. It's a rainy day in Corpus Christi, Texas. Not a lot of students here, but enough for us to continue on. And so today we're going to look at solving exponential and logarithmic equations. So far this semester we've learned to solve, well, you already knew how to solve linear if we just isolate the x. So we've solved quadratic equations, rational, radical equations. We looked at zeros of polynomials, which is just solving polynomial equations. In this assignment, we're going to have some exponential equations and some equations that have logarithms. Remember, equations have a equal sign in it, and the instructions have to say the word solve if it's an equation that you're working with, okay? If we look at our first problem, it says solve the following exponential equation. Well, we solved some exponential equations a week ago when we first looked at our exponent rule. Well, we reviewed exponent rules and looked at exponential functions. And let's see, where are those notes over the stuff? Something like, let's see, here, 2 to the 2x minus 3 equals 16. This was an exponential equation because the variable is in the exponent. That's how you can tell these from all the other types of equations we've solved. And we were doing ones where we had a common base. We were able to rewrite 16 as 2 to a power. And then we'd say, okay, if the bases are the same, the only way these can be equal is if the exponents were the same. So we just dropped the base and set the exponents equal. And at the time we asked, well, what will we do if there's no common base? And I said, well, we'll use logarithms. And what was that problem number 1 that I'm going to do? 3 to the x equals 6. At first glance, you might think, oh yeah, there's a common base. But wait a minute, you can't write 6 as 3 to a power. 3 squared isn't 6, it would be 9. So there's no common base here. So I'm going to write out a strategy for how to solve an exponential equation if there's no common base. So here goes. Here's a strategy that we're going to follow on these first 4 problems. The first 4 problems are exponential equations that don't have a common base. How to solve an exponential equation with no common base. Well, the key is we're going to have to get that that variable out of the exponent. So the first thing you'll do is take the natural logarithm. I'm writing it with a capital L, even though when you're typing logarithms, you shouldn't be typing capital on Pearson. Take the natural logarithm of both sides. So by that I mean we're going to just stick an L in front of each side. Step 2, use the power rule of logarithms. That's one of the big things that logarithms can do, is let you bring that exponent down. Use the power rule of logarithms to carry down the exponent. Step 3, isolate the x. These 3 steps are exactly what we'll do on problem number 1. But I want to make a note here. If there are 2 x terms, like on the one I showed you for problem 1, there's only one x term in it. But what if there had been 2 x terms? So that's what this note is right here. If there are 2 x terms, isolate the 2 x terms on one side of the equation. I'm just going to say on the left. And once you've done that, factor out the x and divide. That's how you isolate the x. If there's 2 x's, you put them together on the same side, factor the x, and divide. It'll make more sense when you actually see an example. But this is just a nice little strategy for how to solve them when there's no common base. If there's a common base, that's generally the easier way to go. Okay? So problem number 1, if I'm remembering it correctly, is 3 to the x equals 6. 3 to the x equals 6. Notice it gives you it tells you, okay, this is one of those rare times. We're going to round our answers using decimals. And there's a possibility for the solution not being a real number. Well, we're going to wind up punching in stuff with logarithms. And there are times when working with the calculator and working with logarithms, you might get some sort of error message. If I had something like this, ln 5.3 minus 9, that's an ln, we get an error, non-real answer. There are sometimes logarithms aren't defined. Well, when is that? Whenever the number after the logarithm, the argument, if that's negative, 5.3 minus 9, would that be a positive number or a negative number? 5.3 minus 9, it's negative. If you have a negative after a logarithm, then you'll get the same error message that you get when you're punching in square roots of negative. Like we know the square root of negative 25 is 5i, but what does this calculator do when I try to punch in the square root of a negative? It gives the error message, non-real answer. If you continue taking a lot more math classes, you'll see eventually that the log of a negative is one of those imaginary numbers. But we're not going to get into that. Okay? So, for our purposes, if you get one of those error messages, then that's telling you the solution is not a real number, or else it means you may have done something wrong, okay? Or maybe you punched it in wrong. But let's follow through those 3 steps I was saying here. Okay, take the natural log of both sides. I'm going to rewrite this, spreading it out a little. And I'm going to put a ln in front of each side. Just out of curiosity, I clicked on the Pearson video before I started this, and in it the teacher is writing an L that looks an awful lot like a 1. That's why I'm making it what's this called, cursive. Okay, I've read recently that the state of California is going to start back requiring cursive writing in schools. I'm not sure that's a good use of time if you must know the truth. How many people write cursive and need to write it? Back in the olden days, people had to write fast, and that was the purpose of cursive writing. Not so sure that that's that essential right now. Okay, so that was step 1, what I did in purple. Step 2, use the power rule. Remember with logarithms, if you have an exponent at the end of the argument, you can move it down in front. So we have x ln 3 equals ln 6. That was the carry down the exponent. Now isolate the x. Well, we don't need to look at this note here because there's only one x. This is what you do if there's two x's, or heaven forbid more than two x's. Okay? But to isolate the x, what would we do? What's the operation going between the x and the ln 3? If we don't see a symbol here, what do we assume it is? Multiplication. So what am I going to do to undo multiplication? Divide. Divide both sides by ln 3. And we have x equals ln 6 divided by ln 3. Don't get carried away. There's nothing you can do to simplify this. Don't think you can cancel the 6 and the 3. No, you can't. This is one of those rare problems where now you've got to punch it into a calculator and get a decimal number. Be very, very careful when punching in this stuff with your calculator. On my calculator, and on most calculators, when you hit ln, it opens parentheses. I believe on Wednesday, the last three problems, no. There were a couple of problems, not the very last one, but problems 18 and 19. We were punching in stuff like this. And I said, okay, if your calculator opens parentheses, you've got to close them. So here's what I'm actually punching in. I'm going to write in those parentheses ln 6, close parentheses, divided by ln 3, close parentheses, equals, and I don't remember, how did it say to round this? Let's look and see. Round to 4 decimal places as needed. Use a comma to separate answers as needed. You don't need to. There's only one answer. So let's see. If I'm going to round this to 4 decimal places, the way the equal sign just means approximately equal. It's just saying I'm rounding. You might be saying, well, wait, you didn't do that, haven't used that symbol before. Yeah, we haven't been rounding decimal numbers. If you just want to put an equal, fine. 1.63. Then we have a 0.9. Are we going to leave that as a 0.9 or make it a 10? Leave it as a 0.9. The digit after the 9 is a 2, which is smaller than 5. Okay, if it's 5 or larger, you would round up to a 10. If it's 4 or smaller, just drop all of that. So 1.6309. Wow, so think about what we've just found. 3 to the 1.6309 power is equal to 6. Punch that in. Right here. Move this a little out of the way. 1.6309. Okay. Not bad if there's just one x in the equation. If there's 2 x's, that's what my note is about. So here's problem number 2. Oh, you know what? Don't write that down. Let me see if I can read. I want a different one. So there's not so many 2's here. Let me see. Oh, if you click help me solve it. Okay, there. That's a better example. the same number doesn't appear so many times. Well, I guess there's still two 2's, but okay. 3 raised to the 7x plus 2 power equals 2 to the x. 3 to the 7x plus 2 equals 2 to the x. Well, there's not a common base. There's no way you can get a common base between 2 and 3. So stick ln in front of each side. Again, I'll rewrite it. So that was the first step. Now carry the exponents down in front. They should go in front of the letter L. This is going to be a little tricky or look a little messy. The 7x plus 2 is going to go in front of the ln 3. Notice how I put the 7x plus 2 in parentheses. If I hadn't, then the only thing that's being multiplied by ln 3 is the 2. But all of this stuff should be being multiplied by ln 3. X ln 2. So this one's not quite as easy as the previous one because there's two different x's. X's on each side. So I say if there's two x's, isolate the x terms on the left. I guess I should have written, you might need to distribute. Here's what you're going to do over here on this side. Both of these terms have to be multiplied by ln 3. So I'm going to distribute the ln 3, but that's not difficult. Just write 7x and attach an ln 3. Then the plus 2, attach the ln 3. So I'm now looking at this note. If there are 2x terms, isolate the 2x terms on the left. It doesn't really matter which side you use, but I usually just put it on the left. So that's going to mean if I want to put the 2x terms on the left, this term I'm going to have to move over to the left. This term I'll move to the right. So you have 7x ln 3 and then a minus x ln 2. I'm moving the 2x terms to the left, and I move the 2 ln 3 over to the right. So that's going to become a negative 2 ln 3. Formally, what I'm doing is subtracting 2 ln 3 from both sides. I'm also subtracting x ln 2 from both sides. But I've isolated the 2x terms on the left. And now we're going to factor out the x. Do you remember how to factor out a variable? There's an x in both of these terms. So I'll just write my x in parentheses. And then everything except the x's, that's what goes in this parentheses. 7 ln 3 minus ln 2. Any questions how I factored that x out? Y'all see what I did? Factor that x out of there. That's how I went from two different x's down to just one x. Now, what do I have to do to get this x completely by itself? Well, what did I say up here? Factor out the x, and what am I going to do to get the x by itself? Divide. Divide both sides by 7 ln 3 minus ln 2. And now, I'm going to do something that my brother does that I don't normally do. But right here, this stuff is canceled. Without a calculator, how about this? 6 plus 4 divided by 2 plus 8. Y'all can do that in your head. What would the answer be? 1. 6 plus 4 is 10. 2 plus 8 is 10. 10 over 10 is 1. What if I punch this into my calculator? If I punched in 6 plus 4 divided by 2 plus 8, it's not going to give me a 10. It's going to give me, what, a 16? Let's see. What did I do wrong? The calculator didn't mess up. I messed up punching it into the calculator. What would I need to do here to make it give me a 1? Well, I need to tell it, do the top first. Right now, it's just following, please excuse my dear Aunt Sally. It's dividing before it does the adding. 4 divided by 2 is 2, then it adds. What am I trying to get at? You need parentheses. If you're punching in a fraction that has more than one number on the top, that top needs to be put in parentheses. The same thing for the bottom. If you have more than one number on the bottom, put it in parentheses. This thing right here is going to be kind of messy to punch in. There's 2 numbers on top, so I've got to have that in parentheses. There's, oh gosh, what do I see? 3 numbers on the bottom. That needs to be in parentheses. Now, I want to go ahead and remember what my calculator does. Every time I hit ln, it opens parentheses, so I'm going to need to close them. So on my calculator, I have to put close, close, or it's going to give me the wrong answer. Like right here, it opens, so I've got to close them. It opens, close them. At the very end, if you don't put 2 sets of parentheses, my calculator will assume they're there and give me the right answer. But on some of the higher order calculators, if you don't put the 2 parentheses here, it'll give an error warning. Something maybe like syntax error. Okay. So let me see. Let me just start punching this in. Parentheses. -2. Here's the negative key. This is the subtraction key right there. Here's the negative key. -2 ln 3 close, close. If I don't put both sets of parentheses there, it's going to give me the wrong answer. Divided by parentheses 7 ln 3 close minus ln 2. This first click, that's the green parentheses, now the red one. Okay. And we have negative, x is approximately, -3 point, no, it's not -3 point, it's -0.31. I forgot to look. How did it tell me to round it? They don't all say to 4 decimal places. Oh, round it to 3 decimal places. Okay? So This one here wants me to round it to 3 decimal places. So let me get back over here. So negative 3.1. Do I leave it as a 4 or round the 4 up to a 5? Leave it as a 4. So negative 0.314. Negative 0.314. There. Negative 0.314. Now, just to try to convince you that what I'm saying is right, that you've got to have those 2 parentheses right here, I'm going to punch it in without those 2 parentheses. If I had negative 2 ln 3, I just put 1 parenthesis there, divided by parentheses, 7 ln 3. What if I had to close this parenthesis? Minus ln 2, close, whatever. You know, it's going to give me, it gave me an answer, but it's not the correct answer. You have no idea how easy it is to get get this correct and then mess up on this, punching this into your calculator. So make sure. Okay? Any questions? The new thing here is this distributing. Just stick the ln 3 after each term. I think the next one's going to have 2 x's. Oh, yeah. Okay. So come over here. Over 3. 6 to the x plus 3 power equals 4. Oh, well, heck, if I'd seen, well, I guess there's 2 of those 2's there, but I guess 6 to the x plus 3 equals 4 to the 2x minus 2. Well, start off by taking the natural logarithm, stick ln in front of each side, and carry down the exponent. Okay? I'm going to carry down the exponent. The x plus 3 goes in front. So you write it like this. X plus 3 ln 6 equals 2x minus 2 ln 4. Are we going to have to distribute on this? Yes? Don't let the distributing bore you too much. What color did I use? Okay. Just stick ln 6 after the x and after the plus 3. So we have x ln 6 plus 3 ln 6 equals 2x ln 4 minus 2 ln 4. This is one of those where you have to look at do what the little note says. If there's 2x terms, isolate the 2x terms on the left and factor out the x and divide. So I've got to isolate the x terms, so how am I going to move this stuff around? I will, let me see. I'm going to move 2x ln 4 over here. So that's going to become a minus 2x ln 4. And I'll move this over here. So it'll be a minus 3 ln 6. So we have x ln 6 minus 2x ln 4 equals, here it doesn't matter which one you write first. The negative 3 ln 6 minus 2 ln 4, or if you want to write negative 2 ln 4 minus 3 ln 6. It's not going to be real pretty. I'll write it as negative 3 ln 6 minus 2 ln 4. It's going to be sort of messy, a messy fraction to punch into your calculator. Y'all caught up with what I've done here? Now once you have the two x's on the same side, we factor that x out. So just write down the x in the parentheses. I'm just factoring a variable out of a messy looking expression. And just write down everything that's left without the x. You'd have a ln 6 and a minus 2 ln 4. After you factor out the x, what do you do to isolate the x? Divide. So divided by ln 6 minus 2 ln 4. Over here, ln 6 minus 2 ln 4. Now, if there's more than one number on top, and I see 4 up here, it needs to be in parentheses. I already have the bottom in parentheses. Let me go ahead and think about when I hit this ln, it opens the parentheses. I've got to close it around that 6. If you don't close it right here, you're going to get a wrong answer. It opens it here. I've got to close it there. So I need 2 sets of parentheses after that 4. If I don't put the 2 sets of parentheses, I'm going to get the wrong answer. Now we're thinking, oh wow, so we're finally using our calculator, and that's only making it harder. That's the worst part of this, paying attention to those parentheses. Let me see. Let me clear this. Parentheses. Negative 3 ln 6 close minus 2 ln 4 close. I remember the old TI-85. That came out before the TI-83, and I remember 30 years ago when I first saw, the TI-85, it was great. It didn't open those parentheses. Okay, so you have to do that close. Then when the 83 came out, and there was so much raving about the TI-83, that's what all the schools were going to be using, I was like, what the heck is up with this? Why do they have that parentheses? You know what? Y'all see where my cursor is? It looks like I have either a decimal point or a minus sign there. I don't, right? No. I guess my pen this is not, ignore that there. I'll cover it up with my cursor, okay? So, ln, oh, well, no, I can't cover it up with my cursor. ln 6, close it. Yeah, there is a mark there. Just pretend that mark isn't there. Now, it looks like a 3, which makes it even worse, but pretend that isn't there. ln 6, close, minus 2 ln 4, close. Oh, and are we rounding to 3 or 4 decimal places? What does it say? Oh, it doesn't say 3 or 4. It says round to the nearest thousandth. Well, what does that mean? The nearest thousandth. Remember your place value. The first digit after the decimal point is a tenth, then a hundredth, thousandth. So rounding to the nearest thousandth is the same thing as saying round to 3 decimal places. So 8.30, leave it as a 7 or round it up to an 8. Leave it 8.307. 8.307. Oh, let me punch that in. Any questions? 8.307. On your calculator, does it open parentheses or does it have a little box there that you type in and something when you hit LN? Are there parentheses or it's a little flashing box? Say, just LN. So when you type LN, it just shows LN. And so you say 6. Let's see. Are you getting the right answers? Okay, great. Oh, wow, this one is nice. It's a sharp calculator. Okay, so you don't have to worry with all of those. Well, you do have to put the parentheses around the top, but I don't think you're going to have.
But if I do so do parentheses and then -2, and then if I click LN, then it'll do its own parentheses for the negative.
Oh, wow. Okay. She has a sharp calculator. It looks a lot nicer, what you're typing in. I think it's going to make it look nicer than what I have up here on this calculator. I'm using a TI-83 Plus, not because I love the TI-83 Plus. I'm using it because that's what I can get free on as my little virtual calculator. Okay. Did I get a right answer there? Yeah. Well, let's do number 4. Oh, this looks hard. Oh. E to the negative 0.56t equals 0.97. We solved some equations that have E in it a week ago today when we were doing that common base stuff. Let me see if I can find them. And we said E was a decimal number approximately 2.718281828.5. Okay. And we said, okay, if you have an E, then in order for there to be a common base, there has to be an E on both sides. And that is your common base. Okay. So E's the common base. This was number 18 on that day, and 19, very similar. But an E on both sides, like on number 4. We're now going to answer that question. It's actually pretty darn easy to solve. We'll use that same strategy, taking LN and putting it in front of each side. Let me rewrite this problem. And stick LN in front of each side. Oh, I'm going to move this on up and cover up all that messy number 3. And this is actually going to work out really nice if you remember a rule about LN and E from the last class meeting. When LN and E are side by side like this, what happens? Cancel out. I think that was your last homework problem, number 20 the last time. see, ln e squared, the ln and e would cancel, leaving a 2. ln e to the ln 6. If the e and ln are side by side with nothing in between them, they cancel. You could cancel here or there. You'd still get an ln 6. Right here, you can't cancel the e with the blue ln because there's a 5 in between them. Only thing you cancel would be these, the red ln and the blue e. If ln and e are side by side, they cancel each other out. That's what's going to make this work out so nicely here. All that's left is a negative 0.56t equals ln 0.97. There's only one, well, it's t instead of x, but since there's not two t's, you don't have to do any of that moving around and factoring. How do I isolate this variable t? What will I need to do to both sides? Divide both sides by negative 0.56. Divide by negative 0.56. This will be pretty easy to type in on my calculator, as long as I remember to close those parentheses right there. Do I need parentheses around the top and around the bottom? No, there's only one number, 0.97 on top. There's only one number on the bottom. So, where's my calculator? Oh, what did I just do? So, let me clear this. I guess it might be a day late and $1 short, but I should have made that calculator a little bigger. ln 0.97, close parentheses, divided by negative 0.56. Of course, if you don't want to type in that 0, just the 0.97, you don't want to put the 0, just the 0.56, that's fine. You think I would have known to look and see. How do I round it? Type an integer, round to 4 decimal places. Okay, so spelled it out. 4 decimal places. So 1, 2, 3, 4. So 0.05, 43 or 44? 44? 0.0544 is right. Because the digit after that 3 is a 9. So round it up. So 0.0544. As my brother says, circle the answer so that you'll know the unpleasant task is behind. You've done it. Okay? Ooh. That's why I don't have that calculator that big. Right here, 0.0544. Any questions there? In this assignment, we're solving 2 types of equations. The first are those exponential equations that don't have a common base. Oops, no common base. Now, starting with number 5 through 10, once you hit number 11, it's all review. I think number 11 is the domain of f is equal to the blank of f inverse. The range of f is equal to the blank of f. I think that's number 11. Anyway, so there's 10 new problems here. We've done 4. Starting with number 5, it's actually sort of, let me write it down, then I'll see if I can jog your memory that we were sort of doing problems like this the last time. It says solve for x. How does this problem differ from the first three? Well, hopefully it's blatantly obvious. log. These have logarithms. We're now solving the logarithmic equations. Okay, logarithmic equations contain logarithms. So, number 5. Log base 6 of 2x minus 8 equals 4. Log base 6 of 2x minus 8 equals 4. Well, when you're solving an equation, you ultimately want x equals, or whatever the variable is you want that variable by itself, like, right here we had t equals, x equals. Even here we have x equals this huge messy fraction there. Okay? So for something like this, we just want it to get x equals a number, but right now we have a logarithm there. How the heck are we going to get rid of that logarithm in order to get this x by itself? Let me see if I can find where we did it the last time. This was problem 4. Oh, what the heck is this? What is this little thing? I never know. Okay, problem 4 looked like that. Log base 5 of x equals 3. To get the x by itself, to cancel out this logarithm, do y'all remember what we did? Whatever the base of the logarithm is, stick that as a base on each side, and it cancels out. And then that leaves you the x equals, in this case, 5 to the 3rd. The one we're about to do is a little bit more involved than that. But not much. What big number am I going to have to put right here to cancel out that logarithm? 6. There. And when we do that, that leaves us just 2x minus 8 on the left. And don't say 24. On the right, that's a 6. The 6 is now the base raised to the 4th power. 6 to the 4th is 1296. Do we now have an equation we can solve without too much trouble? Yeah, how would I go about isolating this x? I would add 8 to both sides. I don't know why I'm showing that plus 8. I haven't done that in a long time, but okay. So what would that be? 1296 plus 8, is that a 1304? Divide by 2. And say it again. What's it going to get? 652. So x is 652. Ooh, let's move that. 652. Now, a word about this thing right here. The solution is not a real number. Suppose you got x equals 1 as the solution. What would you have following here as the argument? If x were 1, 2 minus 8, can you take the log of a negative number? It doesn't matter what sort of a log. If you try to take the log of a negative number, what's going to happen? You're going to get a non-real answer, because a positive number to any power always has to be positive. When we defined logarithms, we said the base had to be a positive number. As a result, the argument also has to be positive. You can't. If you try to take the log of a negative number, you're going to get an error. It's a non-real answer. Is that what you were going to say? I showed them that right before when we were getting started at the beginning of dealing with the exponential equations. You can't have a negative number argument with a logarithm. So for this one, if you put 652 in for x, 2 times 652 minus 8, up here I knew, oh, that's not negative, okay? But if this had been 8 minus 2x and you plug that in, it would have given you a negative and you would have to say no solution, or they say not a real number. And if it's not a real number, what kind of number is it? Starts with an I. Okay, good. Okay, let's do the next one. Oh, there's a big difference between number 6 and number 5. As long as you have it log equals a number, you can turn all that stuff there into exponents using the base on the logarithm to cancel out the log notation. So that's what you need. You need one logarithm equals a number. Here we have 2 logarithms. We're going to have to remember what we were doing 5 days ago. We're going to have to take these 2 logarithms and condense them so it's just a single logarithm. The most basic problem-solving strategy. If you know how to do one type of problem and you're confronted with a new one, try to make it look like the previous one. In the previous one, number 5, we had one logarithm on the left, a number on the right. Well, on problem number 6, we have 2 logarithms on the left, one number on the right. Okay, so the one number on the right is okay, right? But we want it to look like number 5 with just one logarithm. So how do we condense these down to get it just written with one logarithm? Well, do you remember how to do that condensing? You would say log base 6, and the first thing I would ask myself is, will there be a fraction bar? Remember that? You look at this sign here. If there were a minus sign right here, there'd be a fraction bar, but there isn't. It's a plus. So if we're not going to divide, what's the only other thing you can do to arguments? Multiply. So, oh, wait a minute. I see a minus right there, Tony. Does that have any bearing? No. No. It's the sign in front of the logarithm. It doesn't matter what the sign might be in an argument. You're looking at the sign in front. If it's a minus, then you have a fraction. If it's a plus, you multiply the arguments the way you did here. And now I think we're ready to cancel out the log base 6. What big number will I put on each side to cancel out that logarithm? You're turning everything that's written, this line, everything here is about to become exponents. Yep. Okay, so you put a 6 and a 6. Now, on the left, I'll go ahead and distribute the x. We'd have an x squared minus 5x. Be careful, don't say 12. What's on the right? 36. It looks funny, but that's saying 6 squared. 36. That's why I tried to make the 6 look so big. Like it's bigger than that 2. But suppose we go through and we haven't solved this yet, but suppose we go through and we get x equals 3 as a solution. Would 3 be an acceptable solution? What did we say about the things after the logarithm? They must always be what sign? Positive. So right here, if you got x equals 3, 3 minus 5, would that be okay? Oh, wait. Here it's okay. It's okay there, but this is the one that I'm concerned about. 3 minus 5, would we have a positive or negative argument here? Negative. You have to mark out. So realize as you go through solving this, the numbers you get, you may have to mark out one of them. So It seems like it's been a while since we've solved, or since I've solved a quadratic equation with y'all in here. X squared means it's quadratic, so get a 0, and then you have a choice, factor or use the quadratic formula.
This is a simple trinomial, so I think factoring.
I was going to ask him what do they. I was going to ask, what do you think I'm going to do?
Or what do you think he's going to do?
Mm-hmm. Yeah, you've already said it. I'm going to factor. Numbers that multiply together give 36. 1 times 36, 2 times 18, 3 times 6.
No, 3 times 12.
Oh, 3 times 12. Where am I getting through? And
4 times 9.
4 times 9.
5 does it. 6 times 6.
Yeah. Here's all the numbers that multiply together to give a 36. If I draw my 2 sets of parentheses, I'll put X and X.
What do we know about the signs? The last sign's minus.
So,
okay.
Yep, one's positive, one's negative. Which pair of numbers is going to work? Yeah. In order to get a negative 5, how should I arrange the plus and the minus? The minus 9 and plus 4, is that what I'm hearing? Almost done. Set each one of these factors to 0. And the first answer we get is X equals negative 4. The next answer is X equals 9. Am I going to circle both of those answers, or is this one of those where we say no solution? Or I mean,
maybe one of them's okay and one isn't.
If we take this first answer, you sort of have to check. Why am I saying sort of? It doesn't really matter the numbers you're getting. It's just a matter of whether it's positive or negative after the logarithm. If I plug negative 4 in for X,
obviously
log negative. And here too, negative 4 minus 5, negative. The negative 4 doesn't work. When solving logarithmic equations, a student once asked me, can I say that when solving equations with logarithms, we mark out the negative answers? And I said, usually. Okay? But if you want to be 100% sure, you're doing more than that. You're checking and making sure that the number after here, like if you had gotten a 3, even though 3 is positive, it wouldn't work because right here, 3 minus 5 would be negative. But we didn't get a 3. We got a negative 4, which we mark out. And what about the 9? Is 9 okay? Yeah.
I wonder if you type in negative 4 comma 9, do they say, hey, negative 4 doesn't check, or that one of your answers is correct?
Let's see what happens. If you put, is it going to say, hey?
Or is it just going to say wrong? Let's see.
Wrong.
Wrong. Okay. The problem is that negative 4, I remember a multiple choice test bank once for these problems, and it was awful. Because what instead of saying, it'd say solve for X, which of the following is the extraneous solution? Remember, the extraneous solution is a solution you get that doesn't check. Well, because if you punch it into your calculator or Photomath wouldn't give you the extraneous solution. It was terrible. You were never finding the solution to any of the equations. You were finding the numbers that weren't.
Finding the numbers that weren't solutions, basically. But anyway, we don't use that anymore.
Okay, good.
Okay, so we know what to do if there's just one logarithm on the left and one number on the right. Oh, show us paper. Oh, yeah. We know what to do if there's 2 logarithms on the left and a number on the right. Well, what do we do if there's a logarithm on each side? Let's see if that's number 7. Okay.
Oh, actually it is. You're right.
Log 4x plus 1 equals 1 plus log x minus 6.
eventually we're going to have to turn this stuff into exponents. What number will we use as the base to cancel out that log notation?
If it says log and there's no little number, what do we assume it is? 10. It's base 10, okay? The little number here, if it just says log, base 10, okay? Now, well, we know what to do.
If we have two logarithms on the same side, we know what to do. So why don't we make number 7 sort of look like number 6? Let's get both of the logarithms on the same side. At least we'll then have a number by itself on the right, so the right side will look the way we want it to look.
But show my paper.
Oh, God.
So, now follow the logic here. We're going to try to make number 7 look like number 6. Log equals a number. Well, if I do this, with that arrow there, what am I trying to say I'm doing? I'm going to subtract log x minus 6. So it's log 4x plus 1 minus log x minus 6 equals 1. Again, that basic problem solving strategy. Make it look like the one you know how to do. So we put the two x's together. We put the two logarithms together on the left-hand side. Now let's condense it. And the first thing I always ask myself when I'm condensing logarithms is,
do I need a fraction bar? And the answer is yes, because that sign right there.
If this had been a plus, no fraction bar, like up there on number 6. But there is a fraction bar. So we have 4x plus 1 on top and x minus 6 on the bottom. Now, remember something called the common logarithm. If you just write log without a base, we assume it's base 10. Log base 10 can be referred to as log. It's called the common logarithm. So the little number right here is a 10. So what big number am I going to put on both sides to cancel out that logarithm? 10.
All of that stuff right there became exponents to base 10, canceling out the log notation. So on the left side, all we have remaining is that fraction, 4x plus 1 over x minus 6. 4x plus 1.
Plus 1. So over x minus 6. And on the left,
no, on the right.
Excuse me, on the right, I mean. 10 to the first power is a 10. Now, however you want to do think of this as 10 over 1 and cross multiply. Or if you want to say, okay, I'm going to multiply both sides by x minus 6. However you want to do it.
I would cross multiply.
Yeah, normally I do, but I decided 10x minus 60.
I move the terms around in a way so that you decrease the number of negatives and that you pick up. So that's what I would do. I move the terms in a way so I don't get a negative 6x. I get a positive 6x.
I'm going to get
Is that what you're going to do, Tony?
Yep. I'm going to subtract the 4x and add the 60. I think by doing that I'm not going to have any negative numbers. The 10x minus 4x, that's a 6x on the right. And what are we getting on the left? 61. Divide by 6. No. Does 6 divide into 61? No, it's
10 remainder 1. So it's a little bit bigger than 10.
So let's check it. Now, when you check it, all you're really doing is trying to figure out positive or negative after the after the logarithms. 61 over 6 is just a little bit bigger than 10.
4 times 10 point something plus 1.
Is that positive? What about over here?
10 point something minus 6. Is that positive? So that 61 over 6 is an acceptable solution. The exact value doesn't matter. Just convince yourself that the things after the logarithms are positive.
Okay. 61 over 6.
61 over 6. Now, if it turned out you'd gotten something like, suppose we'd gotten something like just, instead of 61, 6, suppose we'd gotten 3. 3 minus 6, you'd have to discard it. And there was nothing else. In that event, that's when you would have chosen, this time they say it's an empty set. Sometimes they say it's imaginary, other times
or non-real.
Non-real. The other times they say it's an empty set. Any questions there?
Okay.
8. This sort of reminds me of number 6. At least we already have the equals a number. On the right-hand side, we have what we want. We have the equals a number.
Wow. A lot of 3s there. I'd seen I would have help me solve it to get different numbers regenerated, but okay.
There's, still right.
You want to write?
Okay.
Okay. In the future, when I look back over what we did, it has both of us writing. If only one person writes, I'm like, oh wait,
where was I gone or something? Okay, let's switch over to my paper. Did you check and make sure that you didn't miscopy it? X plus 3, X minus... Oh, yeah, all those 3s. So, I would... There's really only one correct next step, first step. Just tell me what you think I'm going to do. I'll tell you right now, it's going to involve these 2 logarithms. Condense, okay? Yeah, let's condense them. I'll write the log base 3. Am I going to need a fraction bar? No, so I'm not dividing. There's not a minus sign in front of the logarithm, so I'm not dividing. The only other thing I can do, if I can't divide, I have to multiply. So I'm going to multiply the x plus 3 times the x minus 3. It might look better if I enclose these things in brackets, although it's not mandatory. I think it looks a little better.
You think it does? Oh,
yeah,
okay.
I think so. And now I want to cancel out. This is the form I wanted. Single logarithm equals a number. So I'm going to have to cancel out the log base 3. All this stuff that I've written right here, all of that's about to become exponents. What will be the base of the exponent? 3, so
if in doubt, say 3 on this problem.
So 3 to the log 3 cancels. We're going to have to FOIL out the x plus 3 times the x minus 3. It looks funny, but it's saying 3 cubed. 3 times 3 times 3 is 27 on the right-hand side. I said we'd FOIL this one out first. X times x is x squared. Outer. Minus 3x. Inner. Plus 3x. Last. Okay, minus 9. So we have, well, let's see, the negative 3x plus 3x goes to 0. And, we haven't used the square root method in a long, long time. I think this is a good problem to just remind you of the square root method. The square root method says you can solve a quadratic equation as long as you have some variable quantity squared on one side and a number by itself on the other side. I'm going to add 9 to both sides. I guess I should have just done the little arrow. Either way, we'd have x squared by itself on the left side. What are we going to have over here? 36. And using the square root method, you pick up two possible answers. Remember, quantity squared equals a number. You can drop the square on the left, but you pick up a positive or negative square root on the right.
I think that it's very common for students to forget to do plus minus.
And if you forget it in this case, then you're okay. Because we have a positive or negative square root of 36, that's a plus or minus 6. Are both of those acceptable? We have a positive 6 possibility and a negative 6. If you're one of those people that forgets the minus and only looks at the positive possibility, I think you'd be okay. Negative 6, come up here. Remember, the arguments must be positive. You plug in that negative 6. Negative 6 plus 3, is that positive? No. So if you'd only gotten the positive one, I think you'd be okay. 6 plus 3 is positive. 6 minus 3 is positive. The only acceptable answer is positive 6. So if you're one of those square root people that forgets, you remember the square root symbol, but you forget the plus minus, you would be okay. Mm-hmm. Your answer would turn out okay. Oh, look at that. Look at number 9. That's a mighty interesting looking problem. Let me write it down. Log base 7.
This one looks different from the others. There's 2 logarithms on the left, but they're not log plus log or log minus log. It's log log. Look at how looks like a tricky little problem.
Okay. Do y'all see that there's a big difference between number 9 and number 8 and number 7 and 6? We had multiple logarithms in those previous problems, but they were being added or subtracted. I claim that this problem's already in the format that we need.
It's already one variable. Look at that.
There's only one variable, and I claim it's already in the form that you need it in. You have a single logarithm equals a number. Just ignore that argument there for the time being. Isn't that just saying a single logarithm equals 0? That's that number, I think it was number 6. We just had a single, number 5, where it was just a single logarithm equals a number. We can cancel out that black log base 7. We can cancel it out by turning everything that's written there into exponents. 7 and 7. Oh, yeah. So 7 to the log base 7, that cancels out. What's going to drop down now? What am I going to have written right here? That green log base 7 of z. That stuff just drops down. Now the right hand side is going to change. What are we going to have over here? This says 7 to the 0 power. That's 1. Remember, it was the first thing, when we started all this exponential and logarithmic, it was the first thing Tony wrote on the page, was that definition of 0 exponent. Well, we used exponents, and we didn't cancel out all the logarithms. What do you think we're going to have to do to cancel out this this green log base 7? Same thing, we're going to have to put the 7 and the 7. We do the same thing The 7 to the log base 7 cancels. What have we got on the left-hand side? We just have a z equals 7 to the first power is so. And notice that 7, if you plug it in there, that argument is positive. So 7's an acceptable answer. This would have been a better problem if these numbers hadn't been the same. This is the one time that you didn't have to have the same base on these.
But when would that ever actually happen?
It wouldn't. It's just a
a
theoretical.
textbook
It's just a
problem.
textbook problem.
I
Okay.
think maybe if
But-
this 0 had been a 2, but imagine how big it would have been getting.
Yeah.
7 squared is 49. 7 to the too big. I don't think a calculator can handle 7 to the 49.
Okay, punch that answer in. Punch that answer in.
Oh.
Go ahead and punch it in.
Oops.
Wrong.
7. And there's one more of these logarithm equations, number 10. It's the last one before the review starts. So it's got to be the hardest one. Is this the hardest one?
I don't think so.
This is problem number 6, just regenerated. I remember one semester that it was exactly number 6, but I looked before class to make sure. And it's similar to number 6, but log base 4 of x plus log base 4 of x minus 6 equals 2.
Suppose we get 10 as an answer. Is 10 okay? Would 10 be okay? Yes, because 10's positive. 10 minus 6 is positive. Suppose we go through and we get 5 as an answer. Is 5 okay? No, because 5 minus 6. My point is, just because the answer is positive doesn't necessarily mean that the result's going to be that it's an acceptable answer. Here we need numbers that are bigger than 6 to be our final answer.
So basically the domain set of x values is numbers
bigger than 6. I'd write it out in words. All real numbers greater than 6. Oh, bigger than, you're right. There's only one correct next step. What is it? Or first step. Assuming writing the problem down isn't the first step. So, okay, here we go. We're going to condense these two. Realize we already have the equals a number on the right-hand side. We already have that equals a number on the right. We need just a single logarithm on the left. Do I need a fraction bar? Do I need a fraction bar? No. Wait a minute. I see a minus. That doesn't matter. It's the sign in front. And you were right when you said, no, we don't need a fraction bar. So if you're not dividing, the only other thing you can do to arguments with logarithms is, so x times x minus 6. And once you have it in that form, single logarithm equals a number. You can cancel out the log notation. I'm going to turn everything here into exponents. What am I going to write down here as the base? 4. It's the same as that base there. 4 and 4. 4 to the log base 4 cancels out. They're inverse functions. So we have, here we'll have to distribute the x. What's that going to give me? X squared minus 6x equals 4 squared is 16. And then what? Okay, subtract the 16. That'll give me x squared minus 6x minus 16 equals 0. What do y'all want to do? Factor or quadratic formula? Factor.
If they said quadratic formula, would you have done it?
Oh,
Would you
it's
have
like when I
encouraged
asked you where you want to go to eat today, Tony, and then if he chooses the wrong place, I let him choose again. If y'all had said quadratic formula, I would have said, okay, let's choose again. I'd let you choose again until you choose what I wanted you to choose. Okay, x squared. X and X. I can't, I'm sitting here, it's sort of funny, there's so few students here, but I was looking at I'm having a good time. I was looking at the grades and stuff. Y'all are, not y'all, the people that aren't here seem to still be working through the material, so.
What was it Lily said the other day when she asked can she borrow a pen? And I had so many pens. And I was like, what would you have said if I'd said no? What would you have done if I'd said no or something? And she said, well, I would have left and watched the video later. I was like, oh, okay, well,
I'm waiting for y'all to tell me. I'm waiting for them to tell me. What do we know about the signs? Okay. And now 16. 1 times 16 or 2 times 1 times 16. You see, I've noticed that's the difference between me and you. I put the little times. 2 times 8. 3. There's another one. 4 times 4. Yeah, and you separate them by the commas, don't you? Yeah. I put the little times. Which one are we going to use? Okay, 2 times 8. Now play around with it in your head. What's going to go here? The 2 or the 8 in order to get back that minus 6x? I agree with the 2. That means we have an 8 there. 2x minus 8x gives us that minus 6x. And then we set each factor equal to 0 to give us here x equals negative 2. Here, x equals positive 8. Are they both acceptable? Which one do I need to cross out? Negative 2. I agree. Because right there, negative 2 is negative. Negative 2 minus 6 is negative. 8 is positive. 8 minus 6 is positive. So 8 is the only solution.
Let me see. I think this is it. Am I right? Yeah. Domain of f is equal to the
range of f
number with inverses. X becomes y. The range
y
of f
becomes good.
Yeah.
Okay.
Well, there. So, let me see. Save.
Any questions? Okay. Let's stop recording.